Hey, so we got some difficulties going on with WAMAP questions. Question number 2 here. Like, so many versions attempted so far. So we're supposed to simplify the expression cosine squared of x minus 1 times cosecant squared of x. And for a long series of other attempts, ended up with like this big equation. Cosine squared of x minus 1 in parentheses multiplied by cosecant of x in parentheses equals, and then there's a substitution that's been made, sine squared of x multiplied by 1 over sine, blah, 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 equals sine of x at the end. So, if you get it wrong and you tell it to show the answer, this is what it shows you. And so you're like, oh, just type that in there, which sometimes works. In this case, is not going to work because what WAMAP is looking for is just that single term of sine of x at the end. And the problem has been set to show steps because it's a complicated process. And so when you hit show solution, it's showing you all of the steps involved to get from the original problem through this substitution and that substitution and however many steps are necessary to arrive at your final answer. So you're not going to type all those steps in there. I mean, like, you're going to do them on your paper. But all you're going to type in there at the end is just your final answer of sine of x or whatever you end up with. So that's one issue. So I showed the solution for this exact problem. It starts from the original over here, and I've color-coded the green and the blue parts, and then it made some substitutions. And so there's a missing part of one of the steps that was entered right here in yellow. Sorry, that's the wrong place. Right here in yellow, which should have been negative sine squared of x. And so let's take a look at that, because there are a lot of different types of substitutions that we might see, and sometimes that are harder to recognize than others. So the original problem gave us cosine squared of x minus 1 in green. So let's just look at that. So you can see what the substitution is supposed to be, but how did we get to negative sine squared of x? So cosine squared of x minus 1 right here, the original part of the expression. When I look at my list of Pythagorean identities right here in the middle, there's not an exact match. A couple of things are close. The one I circled in green has not an exact match. It's got cosine squared of theta. Let's just look at one at a time here. So I moved that one over here to the right-hand side. So it's not an exact match. I need it to be an exact match, cosine squared minus 1. The variable doesn't have to be a match, so theta or x, whatever. But so I took the one I circled in green, I moved it over here, and I did a little bit of algebra on it. I just subtracted 1 from both sides of the equal sign so that I end up with cosine squared of theta minus 1, circled in the green highlighter. Okay, that's an exact match for what I've got highlighted in green up here in the original problem. So my substitution needs to be what I circled in pink highlighter, negative sine squared of theta. Okay, and so that's what the solution is showing as my substitution. Alternatively, we could have arrived at the same place from my list of Pythagorean identities if I take the one circled in blue that's got 1 minus cosine squared of theta, which is maybe closer in visual appearance to what I'm looking for, except the 1 and the cosine squared have been subtracted in the wrong order. So a different approach would be to take what I circled in blue here and do a different bit of algebra, take both sides of that equation and multiply by negative 1. And so when I do that, I got negative sine squared of theta on the one side and negative 1 plus cosine squared of theta. And then since this is now an addition, negative 1 plus cosine squared of theta, you can switch the order of the two numbers you're adding, and that's still equivalent. So just wrote it in the opposite order. I put cosine squared of theta first, and then plus negative 1. And then I also simplified all it in one step here. So instead of plus negative 1, I know that's the same as just subtracting 1. So in the green highlighter circle here, cosine squared of theta minus 1, that's equivalent to the one step up from that, negative 1 plus cosine squared of theta. Okay, but the green circle, the green highlighter circle is an exact match for the original problem. So that's where my substitution comes from, the pink highlighter circle of negative sine squared of theta. Okay, so either way, I ended up with the same substitution in this step the solution, I needed negative sine squared of theta. And then also made the substitution for cosecant, which is 1 over sine. And sine squared is sine times sine. So I got sine times sine as a numerator with sine as a denominator. So one of those sines in the numerator is going to cancel with the one in the denominator. And I'd be left with just a negative and sine of x. And so that was my final answer.